When an engine doesn't start or cranks longer than normal, live sensor data on the scan tool is often the first clue. But raw data can easily mislead, especially during cranking, when voltages sag, systems run out of range, and the ECU may only see part of the story. Let's see how to read this data with confidence. During cranking, the ECU interprets sensor voltages against reference values that may be unstable, as battery voltage drops and circuits see heavy loads. Some PIDs are only meaningful under specific conditions. For example, a crank sensor that provides no pulses means the ECU will not see RPM, and readings like MAP or MAF may freeze or post unusual numbers. Always relate scan values back to current system behavior. To know if scan data points to a real fault, always compare actual PID values to what you'd expect for the engine cranking but not starting. For example, a working crank sensor usually gives a non-zero RPM value. If MAP, MAF, or coolant temperature readings are frozen, stuck extreme, or clearly wrong for ambient conditions, that's a red flag. But if battery voltage sags below system minimum, all readings can drift out of range. Reviewing scan data versus what you'd expect under these exact operating conditions is essential. Suppose your scan data suggests a crank or cam sensor isn't signaling. Instead of guessing, next verify if the sensor gets power and ground during cranking. Use a multimeter or scope at the sensor connector, back probing with key on and while cranking, to check for correct voltages and signal pulses. When comparing scan data to what you measure directly, always check against a good ground, not chassis. This isolates if the issue is the sensor, its circuit, or something upstream. Every sensor fault during cranking needs both scan data and at least one direct measurement to prove the case. Start from the scan PID clues, check power, ground, and signal at the sensor, and only rule a sensor failed if the circuit and measurement prove it. Following a structured path from scan to proof saves wasted parts and missed real issues. A single strange scan reading, like 0 RPM, fixed MAP, or out-of-range sensor value, can tempt you to swap a part. But wiring, grounds, reference voltages, or even scan tool miscommunication can all report bad numbers. Never treat one data point as final proof. Always cross-check with related evidence and direct testing before a repair. Always put scan data in context. Verify measurements directly during cranking, and choose tests that turn clues into confident proof before making any repair decision.